Okay, so what about the next part? What about the, what do you call it, the second part? Okay. Well, for 6x plus 1, in other words. Well, in that case, right, notice that we have 6x plus 1. We want to use this, but we need ax minus b, right? We want it, the factor theorem only applies if you have ax minus b. If that is a factor, okay? If this is a factor, all right. Well, is this a, well, let's see if this is a factor. Well, we can't apply it directly since we have addition here, and here we have subtraction. So what do? What we can do is this. We can write this as subtraction, right? You know, if you were to compare ax minus b, right? Like so. You know, you can't use the factor theorem yet because here we have addition. We don't want that. We want subtraction. But can we rewrite 6x plus 1 as subtraction? Yeah. You could write addition as subtraction. It's minus the negative. So here we have ax minus b. Here we have ax minus b. Right? Here we have it where a is 6, b is -1. And again, capital F is the numerator. So 6 times x plus 1 is a factor exactly if and only if capital F at -1/6 is 0. And again, that's because 6x plus 1 is the same as 6 times x minus -1. So 6x minus -1 is a factor if and only if f of -1/6 is 0. That's what I'm testing here. And what do we get when we do this? We actually don't get 0, so it's not a factor. So that tells us 6x plus 1, 6x minus 1, they're not factors of the numerator, right, by the factor theorem. So they have no common factors, the numerator and denominator, thus it's simplified. Okay, are there any questions on that? I know that was probably a little confusing. I hope I explained it well, but are there any questions? Okay. All right. Let's do another one then. So we have this rational. We want to do this sum, okay? We want to calculate it. Now notice 3x plus 2, that's already factored. You know, you can't factor it down anymore. Not only that, right? It's irreducible. Okay, not only that, you know, the denominator, right? It's irreducible. You can't factor it anymore. Let's look at 4x squared minus 1 now. Well, we know that 4 is 2 squared, right? So this is the same as 2 squared x squared minus 1 squared, okay? This is equal to 2 times x squared minus 1 squared, okay? And this, of course, is the same as, and then, okay, so we, in other words, what we get then is this here, which is equal to this, is a difference of 2 squares, right? You know, ax squared minus b squared, right? It's a difference of 2 squares. So this becomes 2x minus 1 times 2x plus 1. So we could factor 4x squared minus 1 as 2x minus 1 times 2x plus 1. Okay? So we factored this denominator. Now we can get the LCD, right? Remember, when you want to add, it's just like with fractions of integers, right? You have to get a common denominator. Okay? You must get a common denominator. Okay, so we have 2x minus 1 2x plus 1, and 3x plus 2. Those are the irreducible factors. It's easy to see that each of their exponents are just 1. Okay? Each of their exponents are just 1. Okay? Now, because they're just 1, we can easily get the LCD. It's just the product. Right? Really, you have 3x plus 2 to the first times 2x minus 1 to the first times 2x plus 1 to the first. Okay? Right? We have that. And so because of that, we have our LCD. Okay? Are there any questions so far? If you have a question, please ask, okay? I really want to make sure everyone understands this. All right. So now remember, just like with fractions, just like we've done before also, you have to rewrite each rational expression so that the denominator, right, is the LCD. Well, we have 3x plus 2 here, so what are we missing? We're missing, right, the 2x minus 1, 2x plus 1 product. Okay, that's what we're missing here. So we put the product in. Remember, what you do to the bottom, you do to the top. Okay? And what you get is this. Right? You have to keep it algebraically the same. Right? That's why whenever you multiply the bottom by, you must multiply the top by as well. Not only that, okay? Not only that, 5x plus 3 over 4x squared minus 1, right? Well, the denominator we factored as 2x minus 1 times 2x plus 1, okay? Now, what are we missing here? 3x plus 2. So we have 3x plus 2 on the bottom. We also put it on top, right? Because of that, right, we get this, right? Remember, we're missing 3x plus 2 down here. So we put it in by multiplying. We do the same to the top, and we get this. Okay, so that's what we get here. Okay. So basically, altogether, we have this rational expression is equal to this. This rational expression is equal to this. The denominators are now the same. So now we can add by adding the numerators, right? We don't add the denominators. The denominator doesn't change, okay? Basically, what we do is the numerators. But again, we want to simplify, so we can't leave our answer like this. No, we can do more work. So we actually have to carry out these products. And that's what I'm doing here, right? The first product we know is 4x squared minus 1. The second product, you just FOIL and you get this, right? 5x times 3x, that's 15x squared plus 10 times x plus 9x plus 6. Okay? And we get this. So from here, we get 16x squared minus 4, right? We distribute. And then we can combine like terms. I mean, here I combine like terms. 10x and 9x is 19x. But now from this product, we can combine more like terms, as I'm doing here. Right? We have 16x squared, 15x squared. That's 31x squared. Minus 4 and 6 is 2. And the 19x is here as well. So this is what we end up with. Are there questions on this? No, excuse me. Are there any questions so far? Okay. So now from here, right, we want to simplify. So we're going to use the factor theorem again. Okay. Actually, let me just fix this because I want to be able to write it out just like I did with the other class. Keep everyone on the same, page. So we want to use the factor theorem, right? We're going to do that again. Our capital F of x here is going to be the numerator, okay? As you can see, right? We also, okay, so we want to know if this has any factors in common with the denominator, right? Okay, well, what about 2x minus 1? Well, here, do we have ax minus b? Looks like we do, right? We could take a to be 2, b to be 1. And then we have 2x minus 1 as a factor if and only if capital F of 1 over 2 is 0. So this is what we get. Capital F of 1 over 2 is 0. Okay? That's what we get here. Okay? And you can see when we do F of 1 over 2, a direct calculation, I did this actually in decimals, you get 19.25, which is not 0. So 2x minus 1 is not a factor of the numerator. Does that make sense to everyone?
Where did the 1 over 2 come from?
So do you see how in this theorem here, right, we have a polynomial capital F and we have ax minus b?
Yeah.
Right? So we want to know if ax minus b is a factor of capital F, which is the numerator for us. This is a factor if and only if capital F, the polynomial, evaluated at b over a is 0. So for 2x minus 1, right, b would be 1 and a would be 2.
Oh,
so that's why we get, you see it? You see it?
Yeah, thank you.
Are you sure you see it? Like,
yeah, because b is 1 and then over a is 2, so that's where it was.
Exactly. Good, good. Okay, good. Awesome question. Are there any other questions? All right. Okay, so for the next one, 2x plus 1, right? For 2x plus 1, okay? We have a. Okay, so again, we want to use the same theorem, right? But notice here we have subtraction. We have addition here, right? So just like before, we have to have subtraction, but we can write this as minus -1. Right? So that's what we have here. So here we get subtraction if we replace 2x plus 1 with 2x minus -1. That's what we do here. So we get 2x minus -2. So to use this theorem now, we're going to, on this factor, we're going to use b as -1 and a is 2. So in this case, we have to evaluate capital F at -1 over 2. And if you evaluate that, you don't get 0, so 2x plus 1 is also not a factor.